welcome to the first episode of Math in the Bubble with your host, Mr. Daly. Um, we've got Dion and Margot on the stream right now, which is great. Hopefully we get a few more as we get used to doing this online learning thing. I hope that you guys enjoy the content that I create for you guys. All right, so on our schedule, we actually were supposed to do stats around about week 9, but a lot of the other teachers are doing measurement to start off their online learning because it's just going to be an easier thing to teach. So this lesson is going to be pretty basic. We're going to go through perimeter and area of triangles and rectangles and combinations of those shapes. And without further ado, I will get to it. So I'm just going to do everything in blue pen on top of it and talk to the screen as I solve these problems. Okay, perimeter. So typically with a perimeter problem, you're given just two sides of a rectangle, and they'll ask you to work out the whole rectangle. So you've got to just know that if it's 850 centimeters on that side, it's going to be 850 over here, and if it's 25 meters over here, it's going to be 25 meters on the top. I mean, it's fairly intuitive, but some of you might not get that. Also, with measurements, you always want to be working in the same units. So at the moment we've got centimeters and meters, so we actually need to change one of them into the other. So I always like to get the numbers smaller. So what do we know about centimeters? There's 100 centimeters in 1 meter, so 850 centimeters will be 8.5 meters, and that would be 8.5 meters over there. Okay, so perimeter is basically just the whole length around a shape. So our P perimeter is 25 times 2, because we've got two 25s, and we're going to add 2 times 8.5 meters. So that'll be 50 plus 17 gets us to 67 meters. Just single meter units because it's a distance. It's from here, it's the distance traveled around a shape. Okay, the units for area are a little bit different. Okay, we're going to do a slightly trickier perimeter problem. So this is about as hard as it gets, but you get different composite combinations of different rectangles, and sometimes they can be kind of challenging to work out. But there's a few distances that have been left off this one. So we've got 7 meters here, but we don't actually know what this distance here is, or this distance here is. So we're going to figure those things out. So we know that the distance along the bottom is 13, and the distance up here is 8. So this side here is going to be 13 minus 8, so that's going to be 5 meters. And then, well, we don't actually need to know, or we do need to know this actually. So this distance is going to be 7 minus 4, because it's 7 meters on the large rectangle and it's 4 meters on the other side. So don't like that. Why does it do that? Let's just so this is 3 meters here. So the perimeter of this shape, we don't actually include this length here. So going around, we have 7 starting from here, plus 8, plus 3, plus 5, plus 4, plus 13. 7 and 8 is 15, 18, 23, 27, 40 meters. Yeah, so that's just for the perimeter. Lag. uh, oh, nice. We've got Eamon, Olivia, Rosie, Elijah also join the chat. Yeah, I don't know how to control the lag, so that's probably to do with my computer. How's the audio anyway? Just a little. I know it hasn't been that good on other streams that I've done. Oh, okay, I'm not going to read those. I'm in the middle of the video. I'm just going to plow through this, and I can talk to you guys at the end. All right, let's get on to area. It's pretty easy. You're just multiplying your base times height, or your length times your width, whichever way you want to think about it. So in this situation that we've got here, we've got 45 millimeters and 7 centimeters. So first off, we want to put them into the same units. So let's work in centimeters. So 45 is 4.5 centimeters. So to work out our area of our shape, we were going to go 7 centimeters times 4.5 centimeters. So I've got a calculator here. This is silly. 3 point. $31.5 centimeters squared, because there's centimeters multiplied by centimeters gets you square centimeters. So that's a centimeter by, that's how many little centimeter by centimeter squares that we've got inside that box. Piece of cake. Okay. While we're on area of rectangles, I just wanted to show you the area of a parallelogram. So, I like to think of a parallelogram as basically like, it's the same as the area of a rectangle, except you've got the rectangle, we're going to imagine the rectangle's here. So the area of that yellow rectangle would be base times height. And then you've just got to think that, well, this has been cut off and pasted over there. So if you cut and paste the area in different places, then it hasn't changed the area, you've just moved the area around. So it slots in there and completes the other side of the parallelogram. So parallelograms are basically just rectangles that have been pushed over. But yeah, you have to use the vertical height. You can't, this height is wrong. do that later. Okay, so your area is your base times your vertical height. Okay, so if we're going to do this little parallelogram, then we've got our vertical height is 2 kilometers and our base is 3 kilometers. So our area of our parallelogram is going to be, should use a different color pen, 3 kilometers times 2 kilometers equals 6 kilometers squared. Units are important in measurement. Usually you're going to miss out on 1 mark per page that you get your units wrong. So it's very common to leave that little squared off and lose a mark. Okay. This is the same problem we had before, except this time we're going to work out the area. So to do this, there's actually a couple of ways you can do it. So the most obvious way to solve this problem is to do the big square plus the little square. So we've got 56, 7 times 8, 56, and our small square, or rectangle, we've got this side, but we need to work out this side. We did that earlier, it was 5 meters. So 5 times 4 is 20. So you're going to get 76 meters squared. The other way that you can work this out is actually by subtracting. So there's also, you could think of this red rectangle and this green rectangle. If we subtract the green rectangle, the red rectangle from the, we are going to be left with the same area. So I might just show you how that is another way of getting to the same answer. So on our red rectangle, this side here is 3 meters because 3 and 4 make 7. So our big rectangle is 7 times 13, 91, and we're going to subtract 3 times 5 for our small rectangle, 15. That equals quick math, Mr. Daly, 76 meters squared. Didn't even have to think about it, I'd already solved it up here. Okay, moving on. We're ready for triangles. Okay. Now, perimeter of triangles. We've actually learnt how to do this already this year. But it may not be obvious upon first look. So we've got this triangle 6 in height, 8 in length. How do we work out this remaining side? Well, Pythagoras. Don't forget about Pythagoras. So this is our A, this is our B, and that's our C side. So I'll just roll through how you do one of those again. So remember with Pythagoras, a squared plus b squared equals, that's not an equals c squared. So 6 squared plus 8 squared equals c squared. So 36 plus 64 equals c squared. So 100 equals c squared. If we take the square root of 100, we're going to get c. So c equals 100. No, wait. What are you talking about, Mr. Dylan? Not 100. 10. 10, and we're working in millimeters, so 10 millimeters. But that's not the perimeter. The perimeter is adding 8 millimeters and 6 millimeters as well to get all the way around that triangle. So that's going to be 24. All right. Here's a composite shape. It's got a triangle and a rectangle in it, and it's got what each unit square is. So if it's 10 meters for this square, we've got 1, 2, 3, 4, 5, 6. So this side is 60. 1, 2, 3, 4. This is 40 meters. This side here is 20 meters, and this side here is 30 meters. How are we going to work out this side? Well, we've got another triangle in here, so we can use our Pythagoras to work it out. So we've got 30 meters and 20 meters. Alright, I'm going to do the quick Pythagoras method this time. So if you want to do it, sub it all into your calculator at once. So this is C. We're going to do the square root of 20 squared plus 30 squared. Put it all in a bracket. We've got some new things. 20 plus 30 equals 50. Not quite. So let's put that into our calculator. 20 squared plus 30 squared gives us 36.06. That's 4 significant figures. So we're going to add that on to all of those other measurements. So we'll start here and finish with C. So 20 plus 60 is 80, plus 40 is 120, plus 30 is 150, plus 36 is 186.06. And our units are meters. Another space there. Okay, last one. Areas of triangles. So the area of a triangle is half of base times height. So half times base times height. Okay, so it doesn't matter what sort of triangle you have, it still works. So base times height, that's a rectangle, right? So basically, any triangle is just half of the rectangle that contains it. So with a right angle triangle, it's easy to see. Well, we've got, if we cut that yellow rectangle in half, we've got the area. So if we take away half of the rectangle, we're left with the area of the triangle. And that also works with an isosceles triangle. So basically this segment here matches up with this segment here. So you've got half of that portion of the rectangle there, and then over this side you've got the second portion matches up with this second portion. So that's also divided the rectangle in half. With the scaling, it's better to imagine a parallelogram. So if I just and remember, so half of this, you can see that the scaling triangle cuts right through half of the parallelogram, and the parallelogram, this is our base from here to here, and our height is from here to here. So if we cut half of that that parallelogram in half, then we're still using the same base times height formula. Alright, let's solve a few problems. So we're going to do all of these units are in meters. So area of this triangle is going to be 1/2 times 8 times 12. Instead of 1/2, you can actually use 0.5. Sometimes that's easy to put into your calculator. I actually prefer to use 0.5. So that equals 48. And our units are meters squared, because we're working out how many little squares. So there'll be 48 little squares inside. Meters squared. Alright, next one is the isosceles. It's pretty easy numbers here. Got area equals 1/2 times 10 times 4. Half of 10 is 5 times 4 is 20 meters squared. Alright, last one, the area of the scaling triangle. So we got 1/2 times base, which is 9, times height, which is 6. That equals 27 meters squared. Alright, last one I'm going to solve for today, and that'll be the end of the video, and then I'll just talk to you guys and see if you guys have got any ideas about how to run some things. Okay, this shape is a combination of a rectangle that's subtracted a little triangle, and that would get us our final shape that looks like that. Right? So we need to work out the area of what that rectangle would be. So I'll just extend that there. Okay, so the rectangle is 10, 20, 30, 40, 50, 60. 60 by 40. Oops. And over here, the triangle is 30 by 20. Okay. So the area of the rectangle is going to be 40 times 60, which is going to be 2,400 meters squared. And our area of our triangle is going to be, which we're going to subtract. We're going to subtract half of 30 times 20. So that's subtracting half of 20 is 10, so 30 times 10 is 300. So our final area of our triangle is 2100 meters squared. Okay, I'm going to stop there. Well, actually, I'm going to show you where I've put a worksheet that you can work on until next week, until Friday. Oh, right. The tap, yeah, yeah. The tapping is, yeah, when I put the pen on the screen, there's a little tap. So that's what that is about. Basically, I need to get a mic that clips onto my shirt, and that should eliminate that audio issue. But I'm working with what I'm working with here. Okay. Schoology. Let's show you guys this. So in Schoology, there is your This Week folder, which you can access the stream. We're going to be at 11 a.m. every Monday, Wednesday, Friday, so long as this is working well. And this staycation triangles activity, you can access that. You can print it off, or you could just have it up on your screen and work out the answers at home. This is something another teacher made up, so I'm just going to use that. So I'll run through the answers for that next session.